Hi, my name is Lennert Mitchell and welcome to my workshop. I'm here today to show you my off-grid solar system, complete with a pair of inverters. I have a computer system here, and this is my way of doing offline or off-grid energy to feed my home. Let me show you more of the system here. So on this wall, we have two, these are DIY battery packs. They both came from Tesla vehicles. We have a battery cutoff system. We have a pair of two 6 kilowatt solar inverters. Once again, the computer system at which I monitor the system. We have cutoff switches for the solar that drives the system offline. And then we have a cutoff switch for the backup batteries themselves for safety. This power basically will backfeed into our main power electrical distribution panel through an interlock switch, which we can walk around and take a look at in a moment. Here is another sub panel that I use to supply power to the system, as well as a transformer to help with balancing the frequency of the power that's generated from the backup system. The system itself, the inverters, are capable of either taking solar power and converting it to electricity, or it will use the battery backup when it's online and functioning, working as a hybrid system, or it can actually draw power directly from the grid to charge the batteries. So you have several different ways of getting to the same goal. The system itself, it's a total of 21.6 kilowatts of backup power, and it essentially can run a house for several days on the most critical systems. The reason why I got into this is that I've always been interested in technology, and especially this is the first home that we've owned where we actually have a solar system attached. One of the downsides about the purchase of the property is that the solar system that is attached didn't have a battery backup. And I wanted to have a means for at least at the minimum to have emergency power if the power from the main grid goes offline, but also to be more sustainable and where I can use this to have a smaller footprint, or rather smaller carbon footprint, getting energy from the solar panels that we have attached to the system, and then basically reducing the amount of reliance on the main grid. My background was essentially based on what I've read and gaining an understanding of how solar power works. The energy comes from the sun, and essentially the solar panels, they collect that energy and convert it to DC energy. And so part of that understanding was, I thought it was a really cool way of getting power converted from the sun without paying for it, since power from the sun is free. If you get it from a source like the utility companies, then you pay for what you use. My interest also was to have a better understanding, because I am a scientist, and one of the things I like to do is explore technologies that are not exactly tied to the type of work that I do. So let's talk about the system that I built. So there's a large DIY community out there that makes battery packs, starting with batteries from different sources, whether they came out of medical devices or laptops or things of that nature. For me to get into this more rapidly, I decided to go with, there's a community that uses the Tesla battery packs that comes out of their electric vehicles. So for example, let me show you the system that I have constructed here. I'm going to remove the panels so that way you'll be able to see the insides. So I'm going to move this one over here. And we're going to take this one off as well. So what you see in each one of these battery packs, each one of these battery packs comes directly from a Tesla vehicle that's been salvaged or for whatever reason dismantled. So the donors were from a 2016 Model X as well as a 2017 Model S. Each one of these battery packs contains 444 batteries. It has about 26 volts DC of energy in each one. So I have a total of 4. Battery pack number 2 here they're wired in a series, and then they run parallel to the battery pack 1 to give us 48 volts of power. The total amount of batteries in the system is 1,776 batteries. And each one of these collectively together, when powering a system, I have 21.6 kilowatts of energy that could be utilized. So the way the battery system is set up, once the batteries are tied in, there is a fuse to basically to prevent any type of system overload. So there's a fuse here. There's a fuse in this system here. And then here, this is a battery management system because these batteries have to be in balance for the amount of energy that they have. So for each set of 2 batteries, I have a separate battery monitoring system, and I'm able to monitor them using these tablets. These are Fire tablets from Amazon, and it runs a little program that allows me to keep an eye on the voltages. And as you can see, what it does, it works to balance the amount of energy between the battery pack 2, and battery pack 1. Here we have a cutoff switch because once again, it's about safety. If I need to work on the batteries, this switch is basically designed to isolate the system, so that way it's just the battery packs only, then I can do whatever maintenance work that's needed to be done. The batteries, they feed energy to both of these 6 kilowatt inverters, and they're from MPP Solar, and they're set up in parallel, meaning that they work together in order to provide essentially 12 kilowatts of power, but 6 kilowatts of energy for 120 volts, and then the other leg 2, 120 volts there. If you look closely at the screen here, you can see that the system itself right now is showing that it's collecting solar power to charge the battery and maintain it. And then, of course, this section here is the load. This is where the power that's been generated will then be fed back into the main distribution panel. And then this one here is basically on standby mode, showing that the battery is fully charged. So this system here runs on 50.2 volts when it's fully charged. And when it's discharged, we allow the battery packs to get down to about maybe 42 volts before we have to recharge it. Let's go over here. So here we have this transformer, and the goal for this transformer is that when this power is been generated from the batteries and then converted to electricity from the inverters, there is a chance that the AC voltage, or rather the AC current, which typically is around 60 hertz, sometimes they get out of balance. So the goal of this transformer is to basically allow the inverters to work in tandem and maintain the appropriate amount of hertz to deliver to the refrigerators, lights, or anything that we're powering off the system. Here on the computer here, all right, so in order to be able to monitor the solar power and the power from the batteries, I'm using a Raspberry Pi module, which is located here. It has a pair of USB connectors, which ties directly into the inverters. And then there's a special software that communicates with the inverters and shows it on the screen. Okay, so it's called Solar Assistant. So if you come closer here, so here's the main dashboard. So you have the inverter section, the solar, what's coming from the grid, the battery, where it's charged at. And then here you can see a series, basically it's a roadmap to what's going on. So right now, we have about 20 watts of load, and it's mostly from the inverters. Here's the power coming from the solar panels, which are on the shed on the other side of this garage. And then here's the wattage from the battery. Now, if you look at this graph here, the way you interpret it is that the red line here is the power coming from the grid when called upon. The blue line is the power is part of the load, so that's your lights, your refrigerator, etc. The yellow is the solar power that's coming in. So right now you can see that the grid power is essentially at zero because it's not running off of the grid. You have very little activity because there's nothing running on the load, but you have solar energy coming in, and that's how it's being measured. Now going back up here to the inverters, so this is the part where you can monitor your inverters. So it'll tell you what the internal temperature is, the bus voltage, the system power, and then of course for each one, it will show you all the necessary information. And of course right now, as you can see, it's running about at 60 hertz on inverter 1 and inverter 2. Further down, it'll tell you about the photoelectric power coming from the panels that are powering the system, the solar panels. So you can see how much is importing. Actually, it's coming in on inverter 1. 2 is not set up. So you can see right now it's about almost 90 volts coming in and 145 watts. Now, that could be dependent upon whether you have a cloudy day or if your solar panels are dirty. We have 4 200-watt solar panels on the garage that generate 48 volts of DC power, direct current power, that feeds through this cutoff switch here. And so with that being said, part of maintaining the system is also cleaning, maintaining the solar panels in order to get the maximum amount of light, in order to create the maximum amount of energy to use to power your system. So this is basically what it is in a nutshell. This is considered to be a hybrid system since it's designed to run on the grid, off grid, and use solar power or off of the grid or the battery. All right, so how did I learn all this? Yes, there is a learning curve. And some of it was human-based, where I had to take time to learn more about solar. I had to learn more about electricity, and then taking those concepts and then applying it to how to utilize this by putting energy from the sun directly into a battery to use. So some of it had to do with learning about wiring an electrical system for a residential. So I have a background in doing that. So I had that as a foundational knowledge. The solar portion, I had to educate myself. Microcontrollers, solar panels, inverters, and what it meant to have a pure sine wave. So all these things I had to learn about first, including the batteries, in order before I can attempt to set up a system. What I found was helpful for me was YouTube videos, communities that I can join, forums of individuals who are like-minded like myself. And so through all those different things, it helped to shorten the learning curve, but there were still things I had to figure out on my own. So when I built the system back in 2021, each one of the battery packs at the time was $1,100. So for the batteries alone, that was a little bit over $4,000. Each one of the inverters at the time was about $1,200. So you add that cost on. The other items, the battery management system, they were about $100 a piece. And of course, you can't have the system without having wiring. So these are basically battery, these are, I believe, size 2 on the AWG, the American wire gauge. So that was about $150 worth of wiring. Because once again, you have to have copper and you want to have the appropriate resistance. So out the door, I spent about, I say around $9,000 for the system. But in comparison to what I would have spent if I would have had a Tesla Powerwall or Powerwalls, I've basically created a system that is a third less, because what I was quoted was over $30,000 for 3 batteries from Tesla. And the other nice thing is that I was able to show the receipts where I could get a partial refund, not so much refund, but rebate through the U.S. government, because this is a system. As long as I showed all the receipts, the solar panels were important, as well as all the parts that were necessary to construct the system. The money that's been saved, the first year we saved about maybe $1,500 on top of what we were paying, and that was just on running the system for approximately 3 to 4 hours a day. The question that most people ask, okay, how much time does it take to break even? So you have to take into consideration, in this case, this system cost $9,000. We got about $2,000 credit from the government, so that takes it down to $7,000. And so I'm projecting probably within about 4 years, the system would have paid for itself. But in the meantime, we could still get the savings from each day that we switch to power and not receive power from the grid, from our utility, and then we realize that on the back end. So about 4 years for payoff, that's where we break even, and then anything beyond that will be just pure gravy, that we can take those resources and put them elsewhere. When we first moved into our home, there was an existing solar system that was set up on the roof of our home. And that system was capable of about 9 kilowatts of energy. So approximately 26 panels, an inverter. And so with that system, the previous owners were leasing the system, which I thought was an unviable way to have solar because you never really own the system. And then on top of it, Edison, which is the utility company, also had their monthly cost as far as how to run the system. So if you buy an underpowered system, you generate less solar, you end up paying more, and then on top of it, you're paying for the leasing. So what we proposed before we closed was, can you prorate what the worth of the system, the value of this system? The system brand new that's on our house would have been about $36,000. And of course, they would love for us to have leased it. They came back with a value of a used system at $21,000, which we incorporated into our financing and paid for the system up front. So now that we are not having to pay for the leasing aspect, we've reduced some of the costs up front. So that system will pay for itself because they're designed to run about 30 years, according to the manufacturer of all the equipment. The batteries, typically, they'll last a long time, depending on how heavily you use them and the amount of degradation for the battery. So we're not doing 0 to 60 with these batteries and using a high amount of energy. We're just using it for powering basic stuff. So the degradation about how much usable energy could be minimized. So for our existing system, we paid $21,000 for that, and we own it outright. We also monitor the system ourselves, so we're not paying for any cost associated with it. And then anything that the battery brings in that we can't use from the system, because the solar panels that are on the house are grid tied. So if the power goes out or Edison has to work on the line for maintenance, that goes offline. The solar means absolutely nothing. You get nothing. But at least with the hybrid system, we're still able to utilize the energy that is captured from the sun during the day, as well as from the secondary solar system that's the solar panels that are set up. So we're well positioned to be sustainable and, once again, save money over time with the realization that these things do take time, and it's one of those things where the more you utilize it, the greater the savings you'll get over time, and so the break-even will come faster. So how do we get this to work? So part of the system is understanding all the different components that we have connected to it. We own 2 electric vehicles, and we also have charging equipment that's associated with it. When we go offline, we do not want to utilize the battery power from here. Yes, it can be done, but it has to be done at a lower amperage. And the reason being, you could overload the system. So part of that is knowing what systems that you want to power when you're switching the power over. So, for example, in this sub panel that I have, it's a 100 amp sub panel. I have it set up to where our Tesla, Model 3 Tesla, and our Rivian R1T, both of those circuits are here. So the first part is turning off the power associated with both of those systems. So this would be turned off, and then this would be turned off. And in fact, what I could do, we can go ahead and take the system offline as a live demonstration. So we're going to go ahead. So now both of our electric vehicles are no longer tied to the system because we want them offline. Okay, so that's the first thing. Let's take a walk outside. We're going to go over to the main electrical panel. Now, one of the big things about working with electrical power is safety. It is always a bad idea not to have an interlock switch installed. This is the main that comes directly from the grid. This is the power from our backup system on the 60 amp breaker. If you notice, this is powered off while this is engaged. It always has to be in this state. If, for example, we didn't have this in place and we forget to turn off the grid and switch this over, it would be catastrophic. You would have a backfeed and probably a small explosion. So this is the same sort of setup if you were running an outside generator. You would just have a different attachment point, but you still have to have this interlock switch. And that's why you have the warnings that I've installed here to let folks know that this is what the purpose of this switch is. Okay, before we switch this over, let me go over, I'm going to check and make sure that both the electric vehicles are off, because once again, we want to double check everything. So we have a wall charger here for the Tesla, so it is off, but we're going to just play it safe by unplugging the vehicle. And now for the electric truck, we're going to go and make sure we plug it. Once again, it's all about safety. Okay, so we know that the system is completely isolated. All right, let's go back over to the electrical panel. Here are those solar panels that I was telling you about earlier. You can see they're a bit dirty and they'll need to be cleaned. Okay, the other thing we want to do is anything that is greater than 20 amps we want to shut off. So ideally, we're not going to run the AC today, but I would turn off the AC. I am going to turn off the SPA, because we have a SPA, because that runs on 60 amps. So basically, this is for running the most critical items to be sustainable. SPA is a luxury, we can have that off. The other thing I'm going to turn off is the breaker for the solar power, because that's directly tied to our inverter, which is next door here, which I'll show you. So this is the main inverter that converts the energy from the solar panels on the roof, and then it feeds through a, I forgot what these are called, the electrical meter here, and then it feeds directly here from Edison, which comes directly here. Okay, so what we're going to do is we're going to first switch off the main power. You see it drops down. This is available now. Actually, we'll switch the solar breaker off. All right, so now we've switched over. So let's go back into the garage and we'll show you what we're talking about here. All right, So if you look here at the screen, so you can see the power is now being fed from the battery directly to the load. And if you look over here, this battery was sitting off, the battery was indicator was showing offline. Now it's showing that it's feeding the load here. So we're currently running off of the battery. If you look here at the screen, I may have to increase the brightness, but it shows the current battery voltage for battery 1, which is around 48 volts. It's 48 volts here. And if we go over to the screen, yeah, because I didn't switch it fast enough. Let me boot the computer up. Typically, I do the switch over fast enough to where there's no interruption of power. But because some of these systems need to be turned back on, we're going to boot the computer up and we'll look at the power that's coming from the batteries, and it's powering things like the refrigerators, the lights, fans, television, any other computers, and of course, anything over 20 amps we don't run. So that would be the oven, the microwave, and of course, you saw that I turned off the circuit for the spa. Okay, so it looks like it booted up pretty quick. The internet should be up. As you can see, it's blinking because that's also on the. It's also on the backup as well. I have a satellite router out here. That's how I'm able to collect information from the main router. We'll know when the system's back up. I have a small Amazon Echo there. This is directly connected to Ethernet, so don't have to worry about that. So I figure about another minute or so, the system will be back up. So we switched the power over. We had to take a couple of minutes to allow the internet to come back up, so all the computer equipment had to be booted. Rebooted the computer, and so now I have two systems to monitor. So the first one is going to be based on the Raspberry Pi that is basically getting information from the inverters as well as the solar. And so it's represented here on the screen. So the name of the company is called Solar Assistant. For about 50 bucks, you can buy the software and then the cost of the Raspberry Pi. So we'll have information about the inverter, the solar. So today it's picked up 0.4 kilowatts of energy. For the week it's done 6.3. Now if you come back down here, so you can see the load is now 857 watts. So that's all the systems that are currently drawing power from this backup battery. And then of course, this is the drain on the battery. Here it's indicating that it's going to drain the battery at 3.1% per hour based on the amount of load. So obviously the more load or items you have turned on, the greater the load and the faster the battery will drain. Now, we can look at this a little bit closer. Once again, you can look at if you want to go back and analyze the how you do over time, you can have a series of charts. You can see how it's over a period of time or hours in this instance. You can see the blue line is the load, so you can see it spiked because we're now on battery power, and we're still generating power from the solar, and we're not using anything off the grid because we've severed our link to the grid. For the totals, if you want to manage your power over time, you can look at over the last 30 days. So I'm pretty sure this is when we had the power outage. You can see this is a spike in the load, and then of course this would correspond a drop in power as well as from the grid. And of course you can map the process of your system. So as you can see, as of today, we have about 0.4 kilowatts of power that's being powered by the battery. The battery has charged 0.8 kilowatts today, and then it used 1.6 watts from the grid. So what will happen is, over time today, it'll basically give you a value of how much the battery had discharged. So right now it's showing 0, but once we discharge enough energy, then we'll get a reading there. And so this is how you can monitor the system for how much you're using and compare it to how much you're not receiving from your utility company. So right now we're completely off the grid. We're powering all the most important items. There's a freezer behind me, so this is also running off of battery power, and everything seems to be happy. So it's a good thing. So that's pretty much how the system works. And of course, I have means of looking at the consumption of power from the panels here. I can do it from the computer. I can even do it from my phone, no matter where I am. So if I'm not home and I know that there's a power outage and the system has been switched over, I can keep an eye on things. And I know that if the power outage goes longer than a day, or we need to be offline for longer than a day, that I have confidence that the panels that I have installed will replenish the amount of power, and then we can turn things on or turn things off accordingly. Now, the final question that I was asked, was it worth it? That's a question that each person has to ask themselves if they want to take upon this endeavor. I'm a person hysterically who likes to tinker. My wife kind of likes that because she knows I can fix things, so that's another story. If you have an interest in being sustainable and doing it without spending a lot of money, then it's totally worth it. This is not for everyone. There are kits you can go out and buy for home systems that you can set up. They're pretty much plug and play. But because of my background in science and construction, I was able to do this, as well as from the community to help me to do it. And I kind of wanted to do it. So I know that I will recoup the cost over time, and I enjoy building it because I learned a lot about being sustainable, what it means if in an emergency, if we don't have power, we're not sitting around in the dark. We can actually do something to help us, to at least with food loss or being able to have access to certain things. For me, it was totally worth it. For anyone else, they have to answer that question of what works best for them.